Question number 1, challenge your understanding kinematics pathfinder. When you start your stopwatch, a particle moving on the x-axis is observed somewhere between the positions x equal to 10 and 12. Sometime during the 4th second, it passes the position x equal to 22, and at the instant 12 second, it is observed somewhere between the positions 55 and 60. When do you expect its arrival at the position 88th meter? So in this question, rather than a particular position versus particular time, there is a range of position and range of times given, and from these ranges we have to find the possible time to reach x equal to 88. One more thing, though it's not given in the question, this particle assumed to move with a constant velocity, that we'll assume. So what's given in the question, say, first we'll collect those things. The particle somewhere between 10 and 12 meters, somewhere means not exact position is not given. And during the 4th second, actually it is a time interval of 1 second. So exactly at what time, that's not given. So given, what's given, it's a range of 1 second. It is passing through this position. And at 12 second, again, a range of x is given. So at every time or every x, there is a range involved. So when do you expect its arrival at position x equal to 88? So it's a different kind of question. So rather than a particular x versus particular time, the given values are in terms of an unknown x in a range and unknown time in a range. Okay, so let's see how to tackle this question. It's a beautiful question. So I'm drawing a graph. Vertical line indicates x position, while horizontal line indicates time. So first piece of information is particle is somewhere between 10 and 12 at t equal to 0. So in this range, there is somewhere the position of particle is not known exactly. Similarly, the other information is given that x equal to 22 in this time range, 3 to 4. So the exact time is somewhere in this range. No, we do not know the value of exact time. Similarly, again, the value of x is given in a range. X lies somewhere in this range at t equal to 12. Exact value not known. And from these pieces of information, we have to find at what time or what range of time the particle is at x equal to 88. So we have to find the possible time here. In this xt graph, I've drawn just a line that passes through one of the points in the ranges given. So this is one possible slope, one possible line. Similarly, other lines can be drawn, which are possible. All such lines are possible which pass through any of these points, any of the points given in the ranges. Okay. So first information, the particle is somewhere between x equal to 10 and 12 at time 0. So first coordinate is for time, second is for x. And the second information is it is at time equal to 3 seconds, or rather a range. From 3 to 4 seconds, it is at x equal to 22. Okay, and similarly other informations are given. So first draw a line of maximum slope. See, consider all possibilities. Line can start from here, it can pass through any point here. So starting from any point in this range and crossing through any point in this range, you can imagine infinite lines. Of those infinite lines, this is the line of greatest slope. You can verify first. The slope of this line is the maximum one. You cannot draw a line passing through one of these points in this range and one of the points in this range, which has a slope more than the slope of A. So this is the slope of maximum magnitude. And what is this? That slope is equal to, slope we can find as delta y by delta x. So 22 minus 10 divided by 3 minus 0. So that is slope of A. So 4. So this is the maximum slope. Now comes the minimum slope. To find the flattest line which can pass through any of these points and any of these points is this line. So that line will pass through 0, 12 and 4, 22. No line can be flatter than this. So this is having a minimum slope, call it B, and its slope is again using delta y by delta x. It is 2.5. Now these lines, check for these lines whether these lines, at what x values these lines pass through at time t equal to 12, because it should match with the given information. So for that we'll have to write the equations of these lines first. So equation of A is, so you can verify x equal to 10 plus 40. Just put the values of times and verify it. At t equal to 0, x equal to 10, yes, this is 0 comma 10, satisfying it. Similarly 3 comma 22 should satisfy. Check x, put the value of 3, this comes out 22. So 3 comma 22 is satisfying. So this is the equation of x. And similarly write equation of b using these coordinates, you can verify. At t equal to 12, these lines, uh, check whether what values of x these lines pass through. So equation of a, in equation of a, put the value of t and solve for x. It's for 58. So it is passing through 12 comma 58. So this point is 12 comma 58. Similarly, from equation of b we can find the value of x. So this coordinate is coming out 12 comma 42. Obviously this point is not possible because it is not in the given range. The range here is from 60 to 55 only. So only those lines are possible which cut this line, t equal to 12 line, in this range from 55 to 60. So maximum slope line is okay. This minimum slope line is not okay because it is not passing through any of the permissible points. So for that we'll have to find again the possible minimum slope of any line. So for that, the minimum slope should pass through 55, 12 55, this point. So you have to draw a line as flat as possible because its slope is to be minimum, because we have found already the maximum slope. Now we are finding the minimum slope. So passing through this point and having as a small a slope as possible. So obviously, if you connect this point to various points on this line in this range, so the flattest line will be the one which will pass through 3 comma 22. So draw this line and extend it. So call it D. So this is the permissible minimum slope. So what is the equation of D for that? So the equation of D is x is equal to A. A is the point here. A is the x coordinate of this point, which is not known, plus slope into time. Slope we can, yes, find because we know 2 points where this D line passes through. So 55 minus 22 upon 12 minus 3. This is the slope. So this is the equation of line D. And since this line passes through 12 comma 55, it will satisfy this equation. And this will give the value of A as 11. Now we know the equation of D, we know the equation of A. So we know these equations. A is the maximum slope line, D is the minimum possible slope line, permissible slope line. And now from these lines, we have to decide where these lines will cut x equal to 88. Then it will give the possible range of time of reaching x equal to 88. So from these two expressions, just put the value of x equal to 88 and find the two times. So this is the time from 19.5 to 21 second. In this time interval, the particle may reach at x equal to 88. So it was a very good question requiring entirely different kind of approach. So you must be enjoying this and you must have learned a lot from this because it's entirely a different kind of question with different kind of approach. Okay, thank you.